Let's take a look at enzymatic activities, 酶的活性. Active center, a cavity on the enzyme surface that binds to a substrate or substrates and serves as the reaction site. Local conformational, physical, and chemical changes in and surrounding the active center generally take place, accompanying the sequential reactions. After products are released, the active center restores its original states and become ready for catalyzing the next reaction. 活性中心，酶表面上的一个凹洞，它与一种或多种敌物结合，并作为反应位点。活性中心及其周围的局部构象、物理和化学变化通常伴随着连续反应发生。产物释放后，活性中心恢复原状，为催化下一步反应做好准备。Enzyme specificity, the structural shape and physical properties of the active center must be made in a way to give a specific docking environment for the substrate binding. 酶特异性，活性中心的结构形状和物理特性必须以某种方式为敌物结合提供特定的对接环境。Next, let's take a look at allosteric effect. 变构效应。If an enzyme has more than one active site, binding a substrate at one active site induces global conformational changes of the enzyme molecule, making the rest active centers more favorable for the substrate binding and catalysis. The example is hemoglobin. Hemoglobin has 4 subunits binding oxygen to one subunit, induce conformational changes, making the rest subunits increasing binding affinity to the oxygen. 如果一种酶有多个活性位点，在一个活性位点结合敌物，会引起酶分子的整体构象变化，使其余活性中心呢更有利于敌物结合和催化。例子是血红蛋白。血红蛋白有4个亚基，将氧气与一个亚基结合，会引起构象变化，从而使其他亚基增加与氧气的结合亲和力。Some enzymes have a regulatory binding site. Binding a regulatory molecule at a regulatory site induces protein conformational changes, either activating or inhibiting the substrate binding at the active center. 一些酶具有调节结合位点，在调节位点结合，调节分子会诱导蛋白质构象变化，激活或者是抑制活性位点的敌物结合。Enzyme activators, coenzymes, inhibitors, and proenzymes. Some enzymes are at inactive forms if they are not needed. The enzymes are activated when required by binding activators or coenzymes releasing binding inhibitor, or by processing the proenzyme by removing the inhibitory peptide fragment. 激活 酶激活剂、辅酶、抑制剂和酶原。如果不需要一些酶处于非活性形式，当需要时，通过结合激活剂或者辅酶释放结合的抑制剂，或者通过去除抑制性肽片段来激活酶。Last part, let's take a look at the environmental factors, temperature and pH. 环境因素，温度和 pH. This is a diagram. This is a enzyme activity. Is the temperature, and this is the curve. The activity curve against temperature change. For human enzymes, most enzymes have a maximum activity around 37 degrees, and when 1 degree decrease, the activity decreases. When temperature increases, the activity also decreases. Once the temperature comes to a certain level, a given enzyme can be denatured and completely lose the activity and end the structure. This is pH. pH activity, enzyme activity against the pH. Look, the curve of the enzyme activity against the pH look like a bell shape. At the optimal pH, the enzyme has a maximum activity, and down the pH, and the activity decrease. Up increase pH also causes the enzyme activity decrease. It's a kind of bell shape. The maximum activity at the optimum pH.